Okay, so still going? All right, good. Everything we do today is kind of in preparation for tomorrow's quiz. And the quiz basically deals with segment lengths in circles. So everything we're looking at deals with that. Any review problems, anything we go over. You're going to have just a review worksheet tonight. There was a long book assignment, but we're actually going to use some of those problems as our review problems in class. And then we will go on and actually do just the review worksheet for the homework tonight. So you don't have book and worksheet, you just have worksheet. This is number 18. We had QP, R, and S. So we had a line coming through here. Was the tangent down there? No, the tangent was on top. Okay. And this might not be drawing exactly to scale, but you get the idea. All right. We were told that we had 12 and 14. It said find QP. So this is 12 and this is 14. This is a right angle. Find QP. Well, I can't find QP directly. I can't. But what I can do is if I ignore QP, if I just kind of pull that aside for now, I can find this length, can I? I can find the length of the tangent, which I'm going to call x right now. So a lot of times when we run into these problems, more advanced problems in geometry, we can't find what we're looking for right away. We have to go find something else first. And then we get to go get what we're doing. You know, it's kind of like, I don't know if any of you ever played any role-playing games on a computer or something like that, where you have quests. And it's like you can never go straight to the quest. You always got to do like 3 little side quests first. And then finally you can get to the quest that you want to do. It's the same idea. How's that for relating it to something that people need to actually find relevant? Vaguely. Okay. Anyway, so we have to set up this way. So in this case, we have a tangent and a secant. So 14 times what? 26 equals x times, because it always has to be 2 segments, x times itself. Yeah, because it's both points of intersection have come to 1, yes.
So when you do multiplying, you always take the outside one?
The outside portion times the whole thing, outside portion times the whole thing, when it's this. Or the way I like to talk about a point of intersection to point on the circle, point of intersection to point on the circle. Okay? Well, so x squared, I don't know what 14 times 26 is off the top of my head, but I can find out. 364. So x is the square root of 364. Now, I'm not going to bother simplifying that because I don't need to. That's not my final answer. I can just leave it like that for now. Now, I've got that. Oh, now I can set up my Pythagorean theorem. Okay. If I call that a squared plus b squared equals c squared. So a squared plus root 364 squared equals c, which in this case is 26 squared. So that's a squared plus 364. 26 squared is 76, I think. Is that right? Yeah. All right, so we subtract 364. That's 312. So a is the square root of 312, and it did say round to the nearest decimal, so I'd go ahead and do that. That's the square root of 312, about 17.7. There we are. If you left the square root of 312, there'd be 2 root 78 in radical form. I think that's as simple as it gets. root 78 in radical form. So it's just a matter of setting it up and solving it. Other questions on the homework? I'm sure there are more. No more questions? 11? Okay, so we have 12x and x plus 4. 12x, and this is x plus 4. All right, so we start with our setup. So that's x. Point of intersection to point of the circle, x times point of intersection to point on the circle. How long is that? 12 plus x equals, it's a tangent, so it's x plus 4 times x plus 4 again. We've got a little algebra to do here. Actually, this is going to wind up being nearly as bad as you think it might. Because x times 12 plus x is 12x plus x squared. When I FOIL this out, this is x squared plus 4x is plus 8x plus 16. And thankfully for us, the x squareds are going to cancel out. So I get 12x equals 8x plus 16. Subtract the 8x. 4x is 16, so x is 4. So if this length is 8, this is 4 and 12. Okay? So the setup again, very key to get the correct setup. Very critical. Once we have it, it does happen. Sometimes we have to factor them. Other times the x squareds cancel out, and we have a much easier problem. And the only way we're going to know that is by actually multiplying it out and checking and see what we got. Other questions? Let's flip ahead then to page 709, I believe. Yeah, 709. Okay. Flip ahead to page 709. And actually, not so much that. Let's go to 712. 712. We've got some pictures there that show some interesting circles, and you have to determine whether AB is the diameter of the circle. So like for number 7, we have 10, 8, 8.9, and 8.9. We're given 10, 8, 8.9, and 8.9. How can I determine if that's the diameter of the circle or not? Oh, by the way, you're also given this. Very important. Is AB a diameter? Yeah. Because it bisects. It's not just that it bisects. It's a perpendicular bisector. If that perpendicular sign wasn't there, I wouldn't know if it's a diameter or not. Because quite honestly, it could still bisect like that, couldn't it? But without it being perpendicular, it wouldn't be a diameter. The only way it's a diameter is if it's a perpendicular bisector of that. What if I have this situation? Move my line tool. There we go. It's supposed to be to the center of the circle. It's really not. So let me work on this for a second. Hold on. There we go. Okay. This is the center of my circle right here. And this chord, this segment right here is 8, and this is 8, and this is x plus 12, and this is 2x minus 1. And these are right angles. What kind of equation can I set up? Yeah, they have to be the same measurement. X plus 12 has to equals 2x minus 1. And again, I get x equals 13 when we do the algebra. But the setup is critical. And this is working with that theorem that we had from Friday that said if two chords are equidistant from the center of the circle, they have to be congruent. And if two chords are congruent, then they have to be equidistant from the center of the circle. The other thing we did determine, even though we haven't talked about it much, since those two chords are congruent, then these two arcs that they create must also be congruent. So if I knew the measurement of this arc, I could find the measurement of that arc. We'll spend more time with arcs starting on Thursday. The other big thing then is just the, sorry, actually let's get the page, is what we were doing last night. And setting up and solving equations like these. Okay, 4, 5, 6, and x. Find the value of x. How do we set up the equation on that? Yeah. 4x equals 5 times 6. So 4x equals 30. So divide by 4, that's 15 halves, which is fine. What if I take the same thing and I'm going to set up with different numbers? I'm going to leave the numbers on there so we can see the different problems with the different numbers. But what if I say this is x minus 2, this is x plus 2, this is, I'll leave that as 4, and this becomes 8, or something like that. How do I deal with something like that? Obviously a little higher level problem because we've got the quadratic now. We're going to have to FOIL this out. So it's going to be 32 equals x squared minus 4. When I FOIL this out, this gives me x squared plus 2x minus 2x cancel minus 4. How are we going to solve that? No, and I can subtract 32. Add 4. Or we could actually subtract 32, but we can add 4 to each side too. Easier. So x squared equals 36, so x equals 6. Okay? So again, we have to be prepared to set these things up just using linear methods or using more advanced methods. How about, let's pick one off the review sheet here. Number 18, x and 28, 20, and 32. Not necessarily drawn to scale, but you'll get the idea. Let's set this one up. How are we going to start out? Where are you at, Jerry? times x equals 20 times 52. Does everybody follow how we got set that up? Everybody see where that's coming from? You got to know where those numbers are coming from. And the first thing I need to see when you're solving problems like this is how you set it up. That's what I need to see first. I'm not even interested in the solution until after I see that. Then we have a little work left to do. That's x squared plus 28x equals 104 or 1040. So x squared plus 28 minus 1040 equals 0. Oh dear. That's going to be a tough one to factor, isn't it? But let's see what we can do. 1040 is an awful big number. My sum has to be 28. So I'm not going to start right with the 1s and 2s and stuff like that because that's not going to get me anywhere. In fact, you know what? When I get numbers that big, a lot of times I'll just go straight to quadratic formula. Because quadratic formula is going to give me the answer every time. And gosh, I don't know. If I can't remember the quadratic formula, maybe I should just look up a little bit. Because it's right there and right there. I got it in two places in the room. Hopefully you'll be smart enough to look at that. So I can look at this and say, okay, so negative 28 plus or minus the square root of 28 squared minus 4 times 1 times negative 1040 all over 2 times 1. Now I've got a little bit of work to do. 28 squared minus 4 times 1 times negative 1040 is 4,944. Now, see if the square root of that is a perfect square. It is not, which means we wouldn't have been able to factor it. We had to use quadratic formula. So that's about 70.3. I know the minus isn't going to make any sense because negative 28 minus 70.3 is going to be a negative 98.3. That's going to be negative 49. That doesn't make any sense. A negative answer doesn't make sense. So I'm taking negative 28 plus 70.3. 42.3, divide that by 2, I get 21.15. So we have to apply our more advanced techniques there. Definitely would fall into the realm of a level 3, high level 3 or level 4 problem. But this is why we spend time looking at how do we solve these equations. I can do it by factoring or do it by quadratic formula. With the large numbers, I chose to go with quadratic formula, which is a good choice because it did not factor. It'll only factor if this thing right here winds up being a perfect square and solves out. They call it the discriminant. It tells me whether or not we can factor it. But yeah, that's basically it. I mean, there's not that much here in this section. It's a pretty, segments, you know, in working with chords, it's a pretty straightforward little section that we're going to take our quiz on. Are there any more types of problems you want me to go over? Any more you want me to set up? Or you think you got this thing? Well, let's find out. I'm going to give you the worksheet, and we'll give you some work time. So how's that for a nice short lesson today? Oops. This up.